Welcome to your scientific method notes, steps to thinking like a scientist. So first of all, what exactly is the scientific method anyway? The scientific method is a set of steps you take to accurately test the answer to a question or to a problem. You don't just have to use it in science class. You can use it all around you every day to help answer questions like, will this brand of whitening toothpaste really make my teeth whiter? Will this brand of diaper really be more absorbent and leak-proof than others? If I add more grooves in these tires, will they grip the road better? I have another little short scenario for you. On your paper, there is a story. So I'm going to go show you a short video about this story, and we're going to help Sally answer a question and answer her problem. So in this scenario, Smart Sally used the scientific method to help her find the answer to her problem. She stated the problem, came up with a hypothesis. We're going to go through the variables that she used in her experiment, the constants, the control, the procedure, and how to accurately take data and graph. And finally, we'll come up with what was Smart Sally's conclusion. So first, let's state the problem. The problem is what you want to find the answer to. You always need to state this in the form of a question. When it comes to Smart Sally, what was her problem? She wanted to know which brand of fertilizer would help her produce more tomatoes. Remember, more tomatoes meant more cash in her pocket. Then you have to come up with a hypothesis. A hypothesis is your prediction of what you think is going to happen in an experiment. This must be an if-then statement, meaning if I do this, then I believe this will be the result. So let's give an example from Smart Sally and her tomato stand. What did she think would happen? Remember in the video, it said she didn't think either brand would work. Go back and read the story on your green paper if you don't believe me. So let's put this into a properly worded hypothesis. Smart Sally predicted, if I use 2 different types of fertilizer and no fertilizer on tomato plants, then the tomato plants with no fertilizer added will produce the most tomatoes, because she didn't think the fertilizer would work. Notice how it's an if-then statement. The independent variable. The independent variable is the one thing that you can change on purpose in an experiment. Keep in mind, you can only have one independent variable. You can only change one thing in an experiment on purpose. If you change too many things, you're not going to know which one of your changes prompted the experiment to take its course. You can only change one thing. So in Smart Sally's situation with her tomato plants, what's the one thing she did differently with each row of tomato plants? She changed the type or the brand of fertilizer she used. She had brand A on one row, brand B on another row, and then none on the third row. The dependent variable is what changes as a result of the independent variable change. It's a change you cannot directly control. In Smart Sally's situation, her dependent variable, how many tomatoes grew on the plants? She can't directly control how many tomatoes grew, but she was able to influence the outcome. So she changed the type of fertilizer she used on purpose, and as a result, because she changed the type of fertilizer, how many tomatoes grew on the plants changed as a result. I mean, come on, you can't tell a plant how many tomatoes to grow. You can't look at a tomato plant and say, come on, tomato plant, you're going to grow me 20 tomatoes per plant. You better do it now or I'm going to rip you out by your roots. They don't get that. You can influence the outcome, but you can't force a plant to grow. The constants. Constants are things that stay the same through each trial of an experiment. Come on, how many of you have little brothers or sisters that constantly annoying you and they're constantly bothering you? Things that stay the same and are over and over and over. Those are your constants in an experiment. So let's think about Smart Sally's experiment. What were some of the things she did the same? We know she changed the amount of fertilizer she used, but she watered each plant the same. You have to do that the same. She had to give them the same amount of sun and the same amount of fertilizer. She used different brands, but the same amount. The control. This one can be a little bit tricky. There may or may not always be a control in an experiment. A control is a trial with no variable, the standard for comparison. Let's go back and think about our variable. Our independent variable was, remember, it was the brand of fertilizer. So we have to have a trial with no brand of fertilizer. Did we have that? Sure we did. Her control was the plants with no fertilizer. She had to compare if the fertilizer was making a difference in the tomatoes produced. So in Smart Sally's experiment, the control, the trial with no independent variable. The independent variable was the type of brand of fertilizer used. A trial with no fertilizer would be the control. Next, procedure. Procedure are simply a set of orderly and detailed lists and steps stating what you will do to complete an experiment. When writing a procedure, you use words like first, then, next, etc. Writing a procedure is so important because experiments have to be replicated to be valid. Think about scientists that are researching things like cures for cancer. If you are a scientist and you're experimenting and you think you have found a cure, you have to be able to let scientists all over the world replicate your experiment to prove that yes, it really does work. Experiments must be replicated. Details, details, details. Orderly, detailed list is a procedure. All right, so once you have your data, you have to make graphs of your data. So let's talk about data collection. Remember that Lost Rocks activity? We talked about the different types of data. Qualitative data is data that describes. An example would be the color or the texture. Remember, you described what color your rock was. Was it gray? Was it brown? Its texture, was it rough or smooth? Things you can describe. Think of those adjectives that you learn in your language arts classes. Quantitative data is measurable, like length, mass, time. Something you can use a ruler or a stopwatch or some sort of measurable number is quantitative data. Data should be collected and presented appropriately. So one of the steps of the scientific method, now that you have data, you have to show your data. A data table is where you would write in results. So for example, let's say this was Smart Sally's. She had all these different tomato plants and she would write in how many tomatoes grew on each plant. A graph is a visual way to display the data from a table. Graphs could be bar graphs or line graphs. A line graph looks kind of like this, and there's also one on your paper. It shows changes over time. That's when you use a line graph. You would use a bar graph to compare amounts. So let's think about Smart Sally. What kind of graph should she have used? She compared amounts, so a bar graph would have been most appropriate. So now let's talk about setting up a graph. When you're graphing data, your independent variable goes on the bottom, which is the horizontal axis, and your dependent variable goes on the side, which is your vertical axis. Draw this to help you remember. If these green arrows are the axis of a graph, the D would go on the side and the I would go on the bottom. So I know it looks like a strange symbol, but draw it on your paper in the space provided to help you remember. When graphing data, whether it's a line graph or a bar graph, your independent variable goes on the bottom, the dependent variable goes on the side. In conclusion, let's talk about the conclusion. There are 3 parts to a conclusion. You must restate your hypothesis. You must say if it was supported or not supported. And you need to give your thoughts or ideas for further research. These are color-coded on purpose because I'm going to show you the sample that is in your notes, and you're going to see how the colors match up. So let's see what Smart Sally's her conclusion should look like. Smart Sally should first restate the hypothesis. My hypothesis, if I use 2 different types of fertilizer and no fertilizer on tomato plants, then the tomato plants with no fertilizer added will produce the most tomatoes, was not supported. So there she gave it was not supported. Fertilizer brand B produced the most average tomatoes per plant. That is the brand I should buy based on my data. Notice how she gave thoughts and ideas for further research. So now that is her idea that she's going to buy that brand based on her data. So look at all the colors and how they coordinate. Restate the hypothesis, tell if it was supported, and give your ideas for further research. Now we're ready to start experimenting. Thank you for listening and watching, and I will see you with your green notes done on the due date.